Hello, I'm Dr. Hazem Riyad, and we are having today a new question about hypothesis testing. So, as we go through the question stem and the answer choices, and then the correct answer and the explanations and the educational objective, as we used to do always. Okay, so we have a question here, and as we said before, there is a strategy. So the strategy is to look for the last line to know what is the examiner is asking us. So here he's asking about the statistical test that is most appropriate to compare blood pressure measurements. So when we think about it, we think about numerical value that needs to be compared. And when looking at the answer choices, we need to look for those that are concerned with the numerical values. So the chi-square is categorical, so it's most unlikely to be the answer. Pearson correlation coefficient is related to the association, not for hypothesis testing, so it's less unlikely. There is one-way analysis of variance or ANOVA, two-sample t-test, and pair t-test that are concerned with numerical values. So one of these three will be our choice. So going to the question, we are seeing that researchers are studying the effect of new antihypertensive medication on systolic blood pressure. They had a group of patients, one group of patients, and has their systolic blood pressure measured before starting and then again after 8 weeks. So there is one group of people before and after. So when measuring a group before and after for a numerical value, we are expecting to be a t-test. And this type of t-test will be a pair t-test because two-sample t-test is concerned with two independent groups measured separately, but comparing the same thing. Here in this case, we have the blood pressure for one group measured before and after. So the correct answer will be pair t-test. So the explanation, as we said, when we have two measurements for the same continuous variable, in this case was the blood pressure, that is measured at two different time points, before and after. It's called paired. So we're measuring paired measurements for one group that is continuous. We are talking about a paired t-test for the analysis of the results. So why our other choices are wrong? As we said, the chi-square test is for categorical variables, not for continuous variables. So categorical like the names, like the gender, like whatever, but not for continuous data, not for blood pressure, not for age, not for, let's say, hemoglobin A1C, whatever. Pearson correlation coefficient, as we said, for the strength of association, not for hypothesis testing, not for differences between the means. One-way ANOVA is, yes, indeed, for the numerical values, but for three or more independent groups, not for one group that is measured before and after or at two different time points. Two-sample t-test is like the pair t-test, but between two independent groups, not pair data of only one group. So to put it all together, and I really like this flowchart, when variables to be compared are numerical, we should look for the number of groups. If we have two groups, that's t-test. So as we said, two groups or one group before and after, it's called paired, and it's called paired t-test, and that's the answer. Or two-sample t-test in case of two independent groups. If three or more groups, that's ANOVA, analysis of variance. Okay, so if categorical, if it's small sample size, we use Fisher's exact test. If large sample size, we use chi-square test. So our educational objective, if when comparing continuous data before and after an intervention, paired paired data of the same group or the same subjects, we use paired t-test. Thank you so much.